All right, welcome back. Today we'll continue with loops, and we'll probably actually get done with most of it and just go on with some exercises to end the day. I did want to remind you that the School of Computing is being established, and outside in front of Avery Hall at 3:30 today, we're having a celebration with ice cream, I think it is. So if you want some ice cream, I don't know what kind it is. It's from the UNL Dairy Store. If you want some ice cream, come on over and hang out at 3:30 today in front of Avery Hall. Everybody heard about that, right? Yeah, no? Yes? Okay. Make sure that you're paying attention to the bits and bytes. I do post it on a weekly basis just as a reminder, but of course when stuff like this comes up that is advertised yesterday for today, it's not going to make it to the Friday retrospective. All right, so in both languages, except for, of course, the printf statement here, this is a valid for loop. And I just wanted to remind ourselves of what each one of these pieces of this loop is all about. The initialization statement, that's the first one, where I've got I is equal to 1, starts I at the value 1, right? So pretty straightforward. The continuation condition is always checked when at the start of a loop, right? Not at the end of a loop. There are loops where the continuation condition is checked at the end. That's called a do-while loop. I won't even go into do-while loops, but if you want to check out the syntax, you can read about it in the textbook, or you can check out the lab next week, all right? I don't cover it because it's fundamentally different, it's weird, and it just behaves differently than for loops and while loops. But the continuation condition is always checked at the start of the loop. If true, the loop executes one more time. Right? Let me know if this is not showing up, because let me give myself some more room here so it snaps. There we go. All right. The increment, and in this case, the increment condition is executed at the end of the loop. Right? Remember that we are on Piazza, we are on YouTube, so if you've got any comments or questions, go ahead and post there, or just raise your hand if you're here. Right? The increment condition goes at the end of the loop. Right? New syntax. We have I++. Remind me, what did that do? It increments by 1. In other words, it adds 1 to the variable I. Right? If you are aware of it, there is a prefix version of this. This is the prefix version. Right? So we're not going to get into it. In fact, you'll probably never see me use this again. I just want to mention it, that it is there. There is a difference between these two. They both add 1 to the value I. But the difference between the two is that one, when you use it in an expression, it retains the old value, and the other one gets the new value. Right? That's only when you're using it in an expression. That's such bad practice that I don't even like doing it. Not only that, but I never remember which one is which. I'd have to be going back to my notes every single time in order to remember that. And so I'm going to avoid that issue entirely, and I'm not even going to use it. If you want to use it, go ahead. All right, just use it judiciously, use it correctly, and understand the difference between the two. It's only important for you to know that it actually exists. All right, I'm not going to cover it any further though. There's also an I minus minus. What do you think that does? Subtracts 1 from the variable I. Right? Not only that, but you can also use compound assignment operators. Right? So what I mean by that is you can go I is equal to I plus equals 2. Right? This adds 2 to the variable variable I. Right? So if you want to go up by more than just 1 or a factor of 10 or something like that, you can use this. This is called a compound assignment operator. Not only that, but it's a little bit more flexible because it's not just going up by 1, it's going up by 2 or 3 or 4. And you can also use it with other operators. You can go with I minus equals 10, and this subtracts 10 from I. Right? You can also use it with multiplication. So if I go I times equals 2, what does that do? It multiplies I by 2. Effectively, what do you end up doing with it? It doubles the value of I. Right? You can also go multiples of 3, 4, whatever. Right? And you can also use division. I divides equals 10. Right? This divides I by 10. But what happens, do you think, when we've got 15 divided by 10? What's the result of that? Well, what is 15 divided by 10? 1.5, right? In math. But what about in computers, programming? 1.5. These are all integers. I is an integer, 10 is an integer. So what happens? Truncation, that 0.5 gets thrown out, and we're left with 1. So beware of integer truncation. Right? Not that big of an issue with multiplication, subtraction, and addition. And by the way, you can use doubles. So you can use doubles. So for example, if I want to add 1.5 to I plus equals 1.5 is perfectly fine. Right?
So I is an integer?
It could be. That's how I presented it so far, but it could be a double too, and it would be perfectly fine too.
So when you're like defining your for loop, you can just say.
Okay, so here, I'll make a note of that. In general, you should avoid double variables as your increment variables. Right? Because, so take 1 and divide it by 3 as a double. 0.33333333. Now, add it to itself 3 times. Do you get 1 back? In math you do, but not in programming. You get 0.9999999, right? And now, is that equal to 1? Nope. So you have floating point errors, you have rounding errors, you have a whole Pandora's box of things that happen when you start to use doubles for your increment variables, right? There's no such thing as running a loop 1.5 times, right? So why even go with a double variable there? Now, you do want double variables when you say use while loops, and we'll do that by the end of the day, right? Okay? Yeah, go ahead.
So for these increments, I can't imagine a situation in which you want to, but can you use I?
I think what you're asking is, can you do this? I plus equals I?
Yeah.
Yeah, you could do that.
Okay.
Let's predict what value it's going to have at this point. I is going to have what value if I do something like this? Honors, GCC, demo. All right, and let's run it. So predict 10 first, and then you add I to itself, so 20. I've got it covered up here. It is. All right. I'm going to have to move that over. I don't think it's on the stream. There we go. 20. Right.
So is that the same thing as just saying times equals 2?
Well, in this case, yeah. But in general, I mean, you can have an entire expression over here. So you could have I plus 20. Right? Now let's predict what this is going to have. So I has a value of 10. For this expression, we add 20 to it, giving us 30. And then we add that to I itself, which was already 10, plus 30. So now it should be 40, right? Yeah, it's 40. All right, don't get fancy. Again, writing clear, concise code is way better than relying on tricks like this. All right? So yes, you can do weird stuff, but the weirder that you get, the less readable your code becomes. Right? Okay. Let's see. That's the increment operator. All right. So that's for loops. Let's take a look at another type of loop called a while loop. So for loops use the for keyword. What do you think while loops use? Yep. While loops use the while keyword. And by the way, both languages are exactly the same so far. Right? The main difference is that the three elements are separated into different lines. And I want to say that a while loop is a little bit more flexible. Right? Here's a truth that we'll talk about later. Any for loop can be rewritten as a while loop. Any while loop can be rewritten as a for loop. So you don't need a language with both of them. You could have a language with only while loops and no for loops or do while loops or any other types of loops. And you can do anything that you want in any other programming language. And there are situations in which it's more natural to use a for loop versus a while loop, and we'll look at one here coming up. But before we do that, let's go ahead and take this for loop and translate it into a while loop. Okay. So my increment, my initialization statement occurs before the while loop statement. So int I equals 1. I'll start my I at 1. We use the keyword while. We still bind it to a continuation condition inside of parentheses. While I is less than or equal to 10, right? Because what did I want to do? I wanted to count to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll print it out, printf. I is equal to I, or %d and the line, and I. Right? And then at the end of the loop, I will go ahead and increment my I. So the initialization condition, the continuation condition, and finally the increment is done at the end of the loop if that's what I want. Right? So let me go ahead and show you that this is exactly functionally the same as before. It prints 1 through 10. Now here's where my comment that it's a little bit more flexible comes in. With a for loop, that increment is always done at the end of the loop. If I want to change that and I want to do it at the beginning, I can. But I can only do that with a for loop. Right? Yeah?
Can you also use if statements to determine when it...
Oh yeah, you can put whatever, you can put arbitrary code inside of this while loop. Right? And there is a break statement, so if I is equal to 5, then break. You might see this sometimes. You might want to use this. I don't generally cover it because it's called, I would consider it what's called a code smell. So just because something smells doesn't mean that it's bad, right? It's kind of like lint, right? But it might indicate that something is rotten, right? Now, plenty of people love rotten food. I don't know, I haven't had it in a long time, but anybody like lutefisk? No, okay. You've had lutefisk and you don't like it. No? All right. It smells terrible. It smells like death. But it's okay if you get used to it or if you dump a bunch of mustard on it or something like that. But many people like lutefisk even though it stinks, right? So there are things called code smells. Patterns or things in code where it kind of smells, right? It has a musty odor, right? And maybe that's something that you want to take a look at and clean up. And I would consider using break statements like this as a code smell. You can probably take your logic for your while loop and reformulate it so that you don't have to use a break statement. Right? So rethink your logic into simpler logic or more concise logic so that you don't have to use these break statements. But you can do this. What happens is when I is equal to 5 inside the loop, it breaks outside of the loop and immediately, regardless of what's up here, and it immediately breaks and goes down here. Right? But again, know that it exists. If you want to use it, fine. But I personally consider it a code smell. right? So again, back to flexibility here. I can change my increment to be at the beginning of the loop. If I do that in this instance, I think I saved it. Yeah, I did. What's the behavior going to be? Predict. So I is going to be 1. 1 is less than or equal to 10. Great. We come into the loop, and what do we immediately do before we print it out? We increment it to 2. Right? So what ends up getting printed first? 2, 3, 4, 5, 6, 7, 8, 9, 10. I is less than or equal to 10. That's true, so we go into the while loop. But then what's the first thing we do? Kick it up to 11. And we print out 11. So this is going to end up printing 2 to 11 instead of 1 to 10. Right? And you can have that bit of control if you really want it. If you want to make sure that your increment is done at the beginning of the loop instead, then you can go ahead and use a while loop. Right? What happens if I completely screw up and I don't do it at the beginning, nor do I do it at the end? What's going to happen now? I equals 1 forever. We're stuck in an infinite loop. You will write code eventually. There, you're stuck in an infinite loop. The solution is not to close out of your browser, restart your computer or whatever. On most systems, it's going to be Control-C to kill the current running process. And you can see that I typed that right here. This -C, Control-C to kill an infinite loop. Okay? Okay. So a while loop is a little bit more flexible. All right? You can place the increment operation anywhere inside the loop. If you don't, though, it could result in an infinite loop. Right? Kill it with Control-C. Right? Sometimes maybe it's Control-X or something like that, but for the most part, like on the CS50 IDE over here, it's going to be Control-C. Now, what happens when I take this over to Java and I go system.out.printf, print f. There we go. So this is going to result in an infinite loop as well, right? And you can see it down there. But if I go Control-C, it's not going to do anything. Instead, there's this big button that hopefully you can see. What should I be pressing to get to stop this process? The stop button, right? If I start the process with the play button, then certainly the stop button will stop it, right? And it kills that process. So a little bit different because you're in an IDE, a full IDE over here instead of the command line over here. Okay. All right. Let's see. Let's see. You cannot do something like this. So with a while loop or with a for loop, we could scope that variable down to just the loop itself, right? Remember up here, when I use this, I created the variable. That variable only exists in that for loop and for the purposes of that for loop. But with a while loop, because my initialization condition is outside and before the while loop, that forces me to necessarily have that widen the scope of that variable. I'm going to define the scope exactly here in a moment, though. Yeah?
You just put the whole block of code into like brackets and then
Yes, you can. So here is one thing that you could do, like putting a fence around it, right? And indenting. Yes, you can have arbitrary code blocks, and you can see here that this will compile as it is right now. Right? And it will tell me that it goes from 1 to 10. Oh, I need to actually increment so that I don't get into an infinite loop here. There we go. This will go to 1 to 10, and then this last statement here will print the fact that it is 11. Right? And if I try to print it outside that fencing, right, then that's going to be a compiler error. Right? Come on, there we go. Because it only exists inside that fencing. Now, that's not very great practice, but rethink what you're doing probably, because that too looks like a code smell right there. Like, why do you have these brackets here? Oh, I can see, because you wanted to cordon off this variable here. Okay, well, it's just going from 1 to 10. Why didn't you do a for loop where you could do that syntactically, right? And so that would be an argument that refactor this code, rewrite this code to have equivalent functionality, but with a better way of scoping down your variable, right? Okay. All right. Let's see. Find scope. Where is scope? All right. So again, another difference here with the while loop is that you cannot scope a counter increment variable to restrict it to a while loop because it is created before, or created, I should say declared before the while loop, right? Now again, what is a scope? The scope of a variable is the section of code in which it lives or is valid or is visible. That's why we literally call it scope, right? Now look through, imagine yourself looking through a scope, like a periscope or just a binoculars or something. Can you see the entire world around you? Nope, only what's within your scope. It allows you to make a focused, like a focused area that you're focusing on, right? And that's what a scope of a variable is. Instead of being wide and available to everything like globals, remember globals are evil, don't use them. You can scope a variable down to as little as possible. In general, it is best practice to limit the scope of a variable as much as possible. You don't want things getting outside the fence, right? You want to cordon them off. You want to limit what are called side effects. You want to limit what your program does as much as possible until you say, okay, well, I can't limit it that much. I can't do what I need to do. I can't do what I want to do. So, okay, then widen the scope of your variable a little, okay? Okay, so which type? Which loop? Which one do you want, right? So observation, first of all, any while loop can be rewritten as a for loop and vice versa. Right? You can take any for loop and rewrite it as a while loop if you really want. So why? Why two? Why two? Right? Why are there two? In fact, there are several other types of loops, do while loops and for each loops, but we'll talk about that in a second. Yeah.
You use a while loop if you don't know when it's gonna.
Okay, good. In general, right? For loops are used when you know how many iterations it runs for, right? For example, 10 or 20 or n iterations, right? For I being 1, or for I being 0, I is less than or equal to n, I plus plus, that's very, very natural. You're putting everything on the same line. You're being concise about it. You're collecting all this stuff, and you know exactly how many iterations you're doing up front. In general, while loops are used when you don't know how many iterations it goes for, right? In other words, it depends on some variable or value or expression, right? That's generally when you do it. And again, you can take a while loop that's natural for this, and you can go ahead and rewrite it as a for loop, an equivalent for loop. Let's take a look at an example here. Let's go ahead and write a loop to compute the number of digits in an integer. Right? There we go. Right? So here's our first challenge activity. Let's go ahead and do it in C over here. Right? So I'm going to go ahead and just declare an integer here, int x, and I'll mash my keyboard. So what is that? 987. Oh, here, let's kick it down. Oops, not that. Let's kick it down here. How many digits are in that thing? 1, 2, 3, 4, 5, 6, 7. Okay, that's the answer that I'm going to expect here. So we obviously need to write some sort of a loop to say there's one digit here, however many digits. So we'll need a counter here, int num digits, and we'll start it off at 0, right? And what I want to do is I want to count the number of digits in this number. If I were to do this with a for loop, do I know up front how many? Oh, we do know up front because you looked at it and you told me. But in general, this is going to be a variable. I could change this to that and the answer would be 5. I could change it to 76 and the answer should be 2, right? I don't know how many digits up front if this is a variable that somebody can set or somebody can input. Just make sure. Now it's 8, right? So if I were to write a for loop for this, do I know up front, a priori, how many times it's going to execute? No. If I knew that, I'd have solved the problem already. If I knew that this is going to execute 8 times, once for each digit, to count up the number of digits, then I would already have my answer. So it's more natural in this case to use a while loop to compute this. So help me out. While, and then do some operation here. Now, here's the number. In fact, what I'm going to do is I'm going to, okay. So here's my number. How do I get the fact that there are 8 digits here? Yeah, go ahead.
So since it's an integer,
Okay.
you can divide by 10 in each iteration and make sure it's not 0.
Okay, so divide by 10. Dividing by 10, what's that going to do? That's going to end up making it look like this, right? But if I divide and do integer truncation, it'll end up looking like this, cutting it off and throwing it away. If I do that again, right, what am I doing by dividing by 10, by the way? I'm just moving the decimal, right? I'm moving the decimal here, and then I'm moving the decimal over here, I'm moving the decimal over here, etc. That little point, that decimal point, is being floated across the number. And now you know why we call them floating point numbers, because the point floats and it's fractional, right? Cool. So eventually I want to get to the point where it looks like this, and then because of integer truncation, it becomes 0. Right? So while x is not 0, okay, not equal to 0, what I'll do is I'll go ahead and divide it by 10. So x is equal to x divided by 10. Now learning one of my new shorthands, is there a way that I could write a more compact version of that? All right. Divide equals 10. There we go. All right, and then of course I want to count, so num digits is equal to num digits plus 1, or another way that I could write that is plus plus. All right. And then let's report the number of digits. Printf number of digits in, and then I've lost the original value of x, but that's okay, is %d and the line. Otherwise, I could save it off into a copy of the variable and manipulate the copy of the variable and num digits. All right, there we go. All right, let's see if this works. Tell me again how many digits there are there. 8, right? Hey, it works. Let's add one more. Compile it. Now it should be 9. Okay, 9. Can I do it like that? Can I have a really massively big number? Nope, it's integer, so it's limited to 2.147 billion and some change, whatever that change is. How many digits are there? 6, 9, 10. Yeah, there we go. Works. What if I went smaller? Just 2 digits. All right. What if I just went 1 digit? And you see me here testing, but ad hoc testing. In contrast to what you did yesterday in your labs, if you, hopefully you did the C version as well, where you did a little bit more rigorous unit testing. The leap year stuff, right? You wrote code to test your code, right? Instead of running the program over and over, inputting in 2001, 2002, 2003, right? You automated that, and you had a nice little report at the bottom, right? That's proper unit testing. What I'm doing here is just ad hoc testing to see if it works, right? It's not repeatable at all, right? And I didn't compile it, but it is correct. Uh-oh. What about this edge case, this extremal case, where I've got a value of 0? How many digits is that, though? 1. What's it going to report? 0. Can't have a number of 0 digits, right? So, add 1 to it? Always? Nope. Now I'm overcorrecting. That one particular edge case, just adding 1 to it screws up all of the other cases that I know are good. So what should I do? Okay, an if statement, right? If x is equal to 0, then I'll report that the number of digits is 0, or 1, sorry. And then put everything else into an else statement and do all this stuff. There we go.
Is it necessary to do the else part of it?
Well, I mean, unless you want them both to execute. Then I'd get 2 reports. One report that says the number of digits is 1, and then the second report says that the number of digits is 0. Right? At least how I've structured this code. Right? There are better ways of doing this, but this is just a toy example. Right? Okay. Now it should, of course, be correct now. There's 1 digit and 0. Negative, there we go. How many digits are in that number? There, that number. 4. Is it going to work or not? Okay, it works. Right? Why? Now instead of going down from a large number down to 0, you're going from a large negative number up to 0. Right? So you're good. Right? All right, would this be able to handle fractional values? Well, if I change it to a double. Right? Now my floating point is already in the middle somewhere, right? I would want to do something else here. At that point, what I would probably do is dump it to a string, count up the number of characters without the minus or plus, or the minus symbol, and then the period symbol, the decimal, and then report it like that. Right? But that's going into strings, and we're not going to go that far. So undo, undo, right? Undo. There we go. All right. So I'll go ahead and put this into the notes. Why that little exercise there, again, what was the point of that exercise other than to get some more practice here? It was to show you that there are situations in which a while loop is more natural. You don't know how many iterations this is going to go up to, because it's dependent on the input. It's dependent on the value of x in this case. So it's a little bit more natural to use a while loop in this case than a for loop. You can always rewrite this as a for loop, right? In fact, I'll show you how. For no initialization condition, while x is not equal to 0, or keep going, and no increment here at all. Right? You can have empty statements within a for loop here, and this will end up being the exactly the same. Right? Okay. So again, you can always rewrite one to the other, but that looks far less understandable than the while loop version of this. All right? Okay. And another reason is syntactic sugar. Syntactic sugar. All right. So again, you don't need a for loop if you got a while loop. You don't need a while loop if you got a for loop. Why do we have these two things? In fact, why do we have I++? Right? You don't need that. You could always just use I is equal to I plus 1, right? In fact, there are languages that do take that kind of approach. Python does not have an I++ operator, an increment operator. Swift, I believe, is another programming language in which they said, we only need one type of assignment operation, right? No, none of this nonsense, right? But we like it because it's syntactic sugar. What is sugar in real life? Do you need sugar? No. But Do you want sugar? Okay, you want ice cream, don't you? All right. Why do we like sugar in our language? Because it makes it more expressive. It makes it more flexible. It makes it easier to use and therefore easier to understand. If you've got a more compact, quicker way of writing out that I is equal to I plus 1, and it becomes part of your lexicon, it becomes part of your understanding of the language, right? Then you can speak that language and write that language much faster, right? It's why we do something called elision all the time, right? For example, do you want ice cream? What did I just do there? I shortened out those first few words. Do you want ice cream? Right? What did I say? I didn't say that. What did I say? Dia, right? What I did is I took a bunch of words and compactified them down. I elided a bunch of the syllables because it's faster. It's easier. It's more colloquial, right? And so you've got things like this. You have the syntactic sugar in your languages to make them more expressive and more flexible. Right? Again, you don't need it, but nice to have. Right? Now, there are some other languages that, no, you don't need sugar. No, you're not going to get sugar. And so, there. Fine. I always forget that when I'm doing Python stuff. I'll always go plus plus, and then it won't run. And yeah, all right, fine. You don't have the plus plus operator. Yes, you are different. You are very special, Python. Right? Right. Here is a common pitfall. So, what's wrong with this picture? I is equal to 0, while I is less than 10, I plus plus, and print it out. Right? It's not the less than or equal to. I'll go ahead and do it like this. Right? I'll start at 1, go up to 10 to be consistent about what we were doing before. What's the one difference there? Yeah. Yeah, there's a semicolon. Right? I wonder what's going to happen with this piece of code. So I'll get rid of all this. There we go. And style it up. Demo. There we go. Except that I don't like its formatting. There we go. I don't know how to do that. Man, style. Options, C, C++. I don't know if there's a style file for it or whatever, but anyway. But what did I just do, by the way? Did anybody see what I did? I want to know about this style thing. What the heck is that? Oops, nope. Man is short for manual, right? Read the manual, read the man pages, or read the manual pages. Or if you want to, be a jerk about it, you could say RTFM, right? Read the frickin' manual, right? style. So it tells me all about style here. Artistic style. Oh, I didn't even know what stood for. Artistic style is a source code identifier, formatter, and beautifier written in C++. It handles the following programming languages, blah, blah, blah. It doesn't look like I can... it doesn't look like I have an option here. What are the options? Tell me, it's not telling me what the options are. But whatever. All right, fine. I was hoping that it could, use different styles. What it did was a GNU style. I like a more modern style where the opening curly bracket is on the same line as the for loop, or the while loop in this case. All right, in any case, that's a little bit digression there. Let's go ahead and run this. What's going to happen? It's going to go into an infinite loop. Why? Same reason where we put when we put a semicolon after an if statement erroneously. I is equal to 1. While I is less than or equal to 10, do what? Do nothing. Right? So I is less than or equal to 10. I is less than or equal to 10. Do nothing, do nothing, do nothing. It doesn't even print this because it's stuck in an infinite loop with just this piece of code right here. Right? Again, kill it. Right? Now, let's find out what happens when we use our nice tool called the WAL flag. What was that called? you're turning on all the warnings, that's referred to as a linter, right? Ah, the linter is able to say, did you really mean to do that? Because you probably didn't, right? This while clause does not guard. It doesn't do anything, right? The statement, but the latter is misleadingly indented as if it were guarded by the while loop, right? Thank you, linter. Yes, I did screw up. I did not mean to do that. Thanks. Right? So be careful with that. The semicolon is misplaced. The linter can very easily catch that. And in Eclipse, of course, you have the stop button. I wonder what would happen in Eclipse with this. Let's find out. System.out.printf. There we go. It doesn't even give me a warning here. There's no linter in the Java language here or whatever, right? Okay. Oh well. Consider the following piece of code. Okay, I think we did this already, but yeah, I'll go ahead and make sure that it's in the notes. That's going to be an infinite loop because we never make progress towards our termination condition, which is the opposite of the continuation condition. This will forever print 0, right? 0, 0, 0, 0 forever, right? Another common pitfall. Look at this piece of code and predict what it's going to do. I increment my I, but what's wrong with this picture? No brackets. Okay. Does that mean it doesn't compile? Yeah, it'll only bind or guard, whatever, however you want to put it. It'll only bind to that first line there. And you can see when I use the A style here, it's showing you that this I++ has nothing to do with this while loop. I'm not even going to indent it for you because it's part of a completely different code block. Let's go ahead and find out what it looks like when I try to run it. Of course, no warnings here because that doesn't look like lint to me. It must have been that you, at least the compiler, and it will forever print out 0 here. Because this ++ is not part of the while loop. If I wanted it to be part of the while loop, I need to make sure that I'm using opening and closing curly brackets. It is best style to always make sure that you are using the curly brackets, even if you only have one statement. Okay? And now it's fine. Yeah?
Why did it print zeros? Was it print?
Because I set it equal to 0. And while a 0 is strictly less than 10, so it's a little bit, it's off by 1 here. And always print 0, 0, 0, 0, 0, 0. Okay? It's going from 0 to 9 in this example. And again, it's bad style. We forgot the curly brackets. Make sure that you are always using them, even if they're not necessarily technically, right? Because you'll get yourself into a rut like this. Yeah?
So you still have the curly brackets, the while loop includes the next line?
Only the next line. Only the next executable line, and that's it. Right? That's why, I mean, you got out of, even if you only have one line of code bound to the while loop, you're getting out of writing 2 characters. Don't do that. Right? You are a huge risk, right? Low reward of saving 2 characters in your code. Right? And of course, then you can make the same mistake and freeze everybody's Zune. Anybody ever heard of the Zune? Yeah, the Microsoft Zune. It is Microsoft, yes. It was Microsoft. I still have my Zune sitting in, it's bricked. I'm sure that the battery's been dead for years. But here's what it looked like. Right? It came out in 2006 or so. All right, here, let's take a look at an image here. It was cool. It was really cool because it provided almost the coolness of an iPod, right? A color iPod with a bigger screen, an FM radio, right? And of course, it was like $50 or $100 cheaper, right? So great on you, Microsoft. I loved it, right? Also because Apple was I reviled Apple at the time, but now I'm a Mac guy now. There's the Zune, right? It was a music player. It could also play videos, right? So on December 31st, 2008, and I experienced this personally, every Zune in the world froze for 24 hours. Then just as mysteriously, 24 hours later, it all started operating again. Why? So here's an actual piece of code that was in a subsystem in the Zune embedded software system. It similar to what you did yesterday, if you did the C version, it had a function that returned true or false depending on whether or not it was a leap year. Was 2008 a leap year? Yep. So, on the 365th day of the year, which was December 31st, 366th day of the year, excuse me, which was December 31st, 2008, this became true, right? For the first time in a couple of years because the Zune had only been out for 2 years. So 366 is greater than 365. This is true. Again, 2008 was a leap year, so this is true. And so now we're at this part of the code here. Is the days strictly greater than 366? Nope. So this is false. And what do we end up doing? Nothing, no else, nothing. Come all the way back up here to the while loop. Right? It is still December 31st, 2008. Right? It is still the 366th day. And so we repeat this process until we get to January 1st, 2009, which now is the 367th day of the year. You can see what we were trying to do here. They were trying to subtract 366 to go back to 0 and then increment the year by 1.
So if they would have said if days is greater than or equal to.
Right there, that's the bug. That was the Zune bug. Instead of going strictly greater than, they should have gone greater than or equal to. And then that bug wouldn't have occurred, right? Yeah?
So if the Zune was disconnected from the Wi-Fi, the date was
Well, it didn't matter. Zune didn't have Wi-Fi, man. You had to plug it into a USB port to transfer files.
okay, so you couldn't change the date on the setting?
You could, but it was frozen, so you can't do anything until one day later when this becomes true, and then everything gets reset. Right? So what was their problem? Their problem was not that the big problem, of course, is that they forgot one character, right? But more fundamentally, what was their problem? They never even bothered to test this in a leap year, right? They never bothered to test this piece of code right here. What happens on December 31st, 2008? If they had done some automated tests like you did yesterday to test that is leap year, right? If they had done some automated tests to test some corner cases, what happens on the first day of a leap year, on the last day of a leap year, on some random day inside of a leap year, right? What happens in a non-leap year, right? They might have tested non-leap years and then everything passed, right? And this one thing fell through the cracks, right? So this, I'm showing this to you to laugh at the Zune and laugh at Microsoft from 13 years ago, but also to highlight the fact that testing is absolutely essential. If you've got a piece of code that is only relevant to one day every 4 years, you'd better make sure that you test that piece of code, right? Okay. So testing is essential. Right? Now, with the last 20 minutes here, in anticipation of ice cream later today, right? I will be there. I have a committee meeting that I'm going to blow off. Let's go ahead and do some exercises. So, I like math. I hope you like math too. Let's do something mathy. Write a program to compute the arithmetic geometric mean of two numbers. So what is the arithmetic geometric mean of two numbers? So if I've got, oops, that's too big. There we go. If I've got two numbers, x and y, I want to compute their arithmetic mean, which is, of course, just x plus y divided by 2. But you can also have the geometric mean, which is x times y, and then you take the square root of that. The arithmetic geometric mean is when these two numbers converge onto the same value, which means that you have to go into a loop because of this definition right here, right? And I'm glad that Wikipedia here has an example. What's the geometric mean of 24 and 6? Right? Well, the arithmetic mean is 24 plus 6, 30, divided by 2, 15, right? But the geometric mean is different. 15 times, 26 times, 24 times 6, square root of that is 12. So 15, 12, these things disagree. What we're going to do is we're going to massage them until they meet and converge to the same number. Right? Not exactly it's not the arithmetic mean of the two numbers. It's somewhere in between there. Right? All right. So on the first iteration of this, we compute the arithmetic mean and then the geometric mean. And then we repeat this process on those two resulting numbers, 12 and 15. Compute the arithmetic mean of those two things, compute the geometric mean of those two things. And you can see that they're getting closer, right? Whereas it was 12 and 15 before, now it's only 13.5 and 13.4, right? They're closer, 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 right? Now, it's going to converge, but it's only going to converge in the infinite, right? Most of you are taking calc or have taken calc or something like that. You know convergence, right? Where 1 divided by x. What is the Wolfram alpha? What does the graph of that thing look like? Graph 1 divided by x. In the positive area, in the first quadrant. What's happening to that function? It's going down to 0. It's converging onto 0. Is it ever 0? No. Nope. Because you can't get 1 divided by x to ever be 0. But it's converging on it. These two numbers are converging together. But will they ever meet? Nope. So what do we have to do? We have to build in a tolerance. If they're close enough, stop and report that as your arithmetic geometric mean, right? In the limit, exactly, right? So, but we can't do limits because a limit is an infinite thing, and computers aren't infinite. I could write an infinite loop, but then I never get my answer, right? So what I want to do is build in a tolerance. If these two numbers are within, say, 1/1,000,000th of each other, stop and report that number, right? And then we can tweak that, right? We can that's our delta difference that we can change that, okay? So I'm going to build in this test case here because we have it at Wikipedia. 24 and 6. So double x is equal to 24. Double y is equal to, can't type today at all. There we go. And I want to compute the arithmetic geometric mean of this thing. Right? So what do I do? Oh, sorry. Here, I'm just going to move this over here. There we go. I need to compute the arithmetic mean, A, and then the geometric mean of those two things. So let's go ahead and do that. Double arithmetic mean will be x plus y divided by 2. And of course, I need to put those into parentheses. There we go. Is there an integer truncation issue here? A plus b is going to be or x plus y is going to be a double, so we're okay there. Double b, come on. And that's going to be, how do I do square root again in C? In C, it's just going to be square root, right, of x times y. Okay. And let's report those two numbers. Printf a is equal to %d, or f, sorry, and the line a. And instead of calling this b, I'll call it geometric mean g. G and G. Don't forget your semicolons. Great. And what do I need to do? LM, link in the math library. There we go. So 15 and 12. So one iteration worked. Great. let's do 2 iterations here. So instead of declaring it again, I'll go ahead and go with a is equal to, now not x and y because those are the original values, but how should I change that? A plus g. I renamed it g for geometric mean. And then a plus or times g. Except wait a second, I just changed a. Okay. So what should I have done maybe? Because now a is going to be different because I change it on line 15. It's no longer the original a. It's no longer this a over here, 15. Right? Maybe that doesn't matter. I don't know. Let's find out. There we go. 13.5 and 12.72. Does that match my expectations over here? Nope. So I do need to make accommodations for that. Help me out. I need to preserve the old value, 12 or 15 or whatever it was, so that I can use it right here before I reset it on line 15.
Establish another variable at the top,
Ah, okay.
or something else.
Temp A, or temp, right, is equal to A.
Yeah.
Now I can change A, and I can use that temporary variable. If you need another variable, create another variable, right? It's a gift that you can give to yourself. Right?
Do we have to put like int or
Oh, sorry. Yes, thank you. It does have to be declared. Right? All right, let's run that again. And now, does that match my expectations? I believe it was 416, blah, 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 blah. Right? And come on, you couldn't give me one more. Right? 24, oh no, here, there. So we can go one more. So do this all again, but I don't need to redeclare temp anymore. Instead, I'll just put A into temp, change A, change G based on the previous value of it. And let's see if we're converging and even closer. 4, 5, 4, 5. Oh man, we are so close. We're only 1/10,000th off at this point, right? And is that correct? I think so. 4, 5, 8. Is that what I got? Yeah, 4, 5, 8, 171. Or nah, that's close enough, right? But have I written a loop here at all? If I want to keep doing this over and over and over again, right? Should I do copy paste, copy paste, copy paste? No, that's called copy pasta. And now it's entered the internet lexicon at this point. But I believe we're taking credit for it, we computer scientists, because that's copy pasta code. You don't do that, right? If you want this piece of code that I just copy pasted to be repeated, you put it into a loop, all right? So let's do that. I don't need that, I just need to declare it. And what I'll do is I will take one copy of this and I will surround it in some sort of a loop, right? So loop. Do the same thing over and over and over again until what? So what kind of a loop do we want here? A for loop or a while loop? A while loop, because you don't know how many iterations. I mean, if you said, I don't care about convergence properties, just go ahead and do this 10 times. Maybe you have an argument there for a for loop. But here, I want to execute this loop over and over again until they're close enough, until they converge to my tolerance. So let's build in a tolerance. Double delta. Right? How small do you want to go? Can't go very small. Let's just go with 1/10,000th because that's what I've observed down here. Okay? Now, while A and G are more than delta apart from each other. Right? There's my first, again, that's not real code, right? Right? So let me put that into a comment. This is another technique that you can pick up, right? Describe what code you want by outlining it as a bunch of comments. I want A and G to be close. I want them to converge. So while they're delta apart from each other, more than delta apart from each other, go one more time. until they get closer and closer and closer, and they're to within less than a delta of each other. So if A and B continue as long as A and G are more than delta apart from each other. Now, how do I codify that? How do I write that into code? A minus G, so that's their difference, right? That's how far away they are from each other. Well, that's greater than delta. Keep going. Now, you got to be careful here. It does oscillate. So the difference can go positive, negative, positive, negative, positive, negative. What if the difference is immediately negative? You stop, right? So in this case, it's going to work, but it can oscillate, right? So how do I want to make sure that I'm, there we go. Absolute value, abs, of those two things. Hopefully this breaks. Yep, that's in the math library. Hopefully it breaks though, and it doesn't work. Come on, really? Well, okay, it certainly didn't give me the same results anymore, right? I'm trying to think of what I could do here. 100, kick it up a notch. Nope. All right, so 600. You need to be bigger, I guess, maybe. It's less well-defined for negatives. There you go. If they're both negative, I think you're okay. But if I'd have to think about that. I'd have to read the article again. But 24, and let's go back to 6 here. All right. So what is I was unable to break it here. I wanted to break it to highlight the fact that abs is wrong. Abs is short for absolute value. Let's RTFM the man pages on absolute value. There we go. So what types does abs take? An integer, and it gives you an integer. Are these integers? Nope. They're doubles. So which one do I actually want? Come on. All right. Scrolling's too quick here. All right. I don't see anything. There's also labs for longs and labs for long longs. Right? And C also maybe? No? Notes. Labs, abs. There we go. Fabs. That's probably what you want. Man, fabs. It's more fabulous. What does it operate on? Doubles. If you used abs, what ends up, it's perfectly fine to use abs, but what happens then? It becomes an integer and you lose precision. So we won't use abs, we'll use fabs. Right? Yeah? No, it is not. This is an artifact of something that we'll get into in the next couple of weeks as we define our own functions. C has function, C does not have function overloading. Java does because it's an modern object-oriented programming language. Because it operates on different types, in C I have to have abs, I have to have fabs, I have to have labs, all these different named functions for different types. In Java, you can have the same name, abs, with different types, and you're perfectly fine. The compiler is smart enough to figure out which one you meant based on what you give it.
You just do like abs dot double or something.
Well, math. No. We'll take a look as we translate this over in the last few minutes here. Right? But I wanted to make sure it works first. So there we go. And that's to within a 10,000th, right? If you want more sig figs. All right, now they're dead on, at least for the first 6, right? Let me go ahead and print out even more significant figures here and see just how off or how close we are. And there you go. And you can see that it's within those digits, which I'm sure matches up with this delta over here. Right? Of course, if you have a really low tolerance, you're accepting that you're not going to have any precision at all. Right? Question?
So is that why like C++ was made to like handle
C++ was an add-on for object-oriented programming concepts that came later, yes. And those are not necessarily present in C because with C we like to be very conservative. They don't like to add stuff at all. Every 10 years it's updated, but even those are only small tweaks. Right? Okay, let's take this code and let's Javaize it. No, that's not what I wanted. Copy. Come on. I want this code right here. Copy. There we go. There. And clean it up. What's the difference? I don't have square root anymore. I have math dot. I don't have fabs anymore. I have math.abs, and just abs, right? And likewise, square root. I don't have printf, I have system.out.printf, or println, or print. Since I'm using placeholders here, I'm going to go ahead and go with printf. And that was it. It's exactly the same. Right? So again, you might be wondering, well, darn it, if the languages are so similar, why do we have so many programming languages, right? Or often I'll get asked, what's your favorite programming language? Or what is the best programming language, right? And so at that point, I like to quote Winston Churchill, one of the original programmers. He didn't say this, but he did say, the original quote was, democracy is the worst form of government there is, except for all the others, right? So Java is the worst programming language that there is, except for all the others. C is the worst programming language there is, except for all the others. What is the best programming language? English, right? We're not there yet, though. Being able to tell a computer exactly what to do and it being able to understand you exactly what you want, right? We barely have decent voice recognition still. You can tell Alexa what you want. We've got an Alexa, and she doesn't understand a damn word that we say, right? You ask her for a baseball score, and she'll give you some random actor or something named Baseball or whatever. It's absolutely terrible. So they don't even have good voice recognition yet, or perfected voice recognition yet. How can you expect to tell a computer, I want you to add up all the numbers from the last quarter, and then give me a delta means variant blah 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 blah, right? We're not at Star Trek level yet. They do that in Star Trek because they're 400 years in the future, right? That's the perfect programming language. Just telling a computer what you want and it doing exactly what you wanted, right? So there is no good programming language. People hate programming languages. And so when somebody is forced to write Java or forced to write C, and they say, darn it, I really hate this aspect of this programming language. You know what I'm going to do? I'm going to write my own programming language, right? And I'm going to fix all these things that I hate about this programming language. And guess what? You now have, instead of 20 programming languages, you now have 21 programming languages. Enough people do that, and you have hundreds of programming languages, right? And there's a famous XKCD about this. Standards. All right. XKCD, are we aware of it? Oh no, it's an online webcomic, kind of nerd-oriented, computer science-oriented. All right. There we go. Situation, there are 14 competing standards. This is ridiculous. We need one universal standard that's better than all the others. Yeah. Now there are 15 competing standards, right? Just because you think that you can improve on something doesn't mean that other people will have the same opinion. Just because you like Java, there are going to be plenty of people out there that don't like Java. And it's completely subjective at that point, right? And that's why we have so many programming languages that do things in a slightly different way, because everybody has an opinion, everybody wants to make their own language. Right? Yeah?
Does it ever get to the point where an idea is like impossible to realize?
Oh, maybe, I don't know. Give me an example. I could dream pretty big, I don't know. Can't do stuff on Star Trek. right? You can't tell a computer exactly what you want, and it does exactly what you want, right? So
like C is imperative or whatever you.
oh yeah, C is imperative. Java is object-oriented, but they evolve, right? Java has been changed over the years to add more functional style stuff to it, for better or worse. I'd say for worse, but again, it's all subjective, right? Yeah.
So the double in Java holds more.
Nope. The double in Java is exactly the same as a double in C.
When they print it, was it more?
Oh no, it's not. It's let's see.
Oh, never mind.
Yeah, because I printed 20 digits of accuracy. The difference though is that Java is not making a guess as to what those lower order digits are. C over here is making a guess, and I'm sure that that guess is based on whatever garbage was in the memory to begin with. Right.
Really?
That's my guess. That's my guess. Okay.
Why wouldn't it know what it is though?
Because I mean, you're just doing some numerical tweaking, right? And whatever happens at the lower end, we stop that by saying I only care about this many digits of accuracy. Right? I mean, I can print out pi to, or I can print it out to say 100 digits. Right? Now, do doubles have 100 digits of accuracy? No. So that's all effectively garbage. Right? And then eventually it gets to 0 garbage, but it's still garbage. All right? Yeah.
Just really quick, what does it mean for Java to be object oriented? Like, what is that?
For Java, it has objects. It's class-based object-oriented, meaning that here's a very simple example. There's no global function square root.
Right.
Every function belongs to a class. In Java, everything is a class or it belongs to a class. You can't have just this stuff out in the ether in the global namespace like you can over here in C, where you've got square root, right? That just exists globally. You can have functions that exist outside of classes. Well, but in C you don't have classes, right? C++ you have classes, right? And the idea with object-oriented programming is the big four. You have, well, big five. You have objects, and however you realize those objects. You have abstraction, encapsulation, inheritance. So you can have classes and subclasses inheriting behavior from their superclasses. And then you have polymorphism, where you can write one piece of code to rule them all. And we'll get into that at the very end of this course a little bit, but that's more of the focus of computer science too. All right. Have a good weekend, and remember your ice cream at 3:30.